Can you all come on video and can we have an interactive session so that we will be able to learn well and take back key learnings. I'll ask a couple of questions now. Please feel free to unmute yourself and tell the answer. What is a recommender system? Have you seen any recommender system? Do you have any examples of recommender systems that you have come across? Anybody would like to answer? Okay.
Okay.
Yeah, go ahead.
Recommender systems are smart systems which recommend stuff based on activity.
So basically we have items, we have users in recommender systems, and these items are recommended to users based on particular algorithms that are there. Can you give me some examples of recommender systems that you have seen in your everyday life?
Like YouTube algorithm.
Yes.
Or Instagram.
Yes. So those are media recommenders. Can you give some examples related to e-commerce?
Shopping websites.
Yeah. Would you like to tell some names?
Flipkart and Amazon giving us the suggestions of a particular item.
Okay. So all of you understand that we have items and we have users. So when the user recommend a system, when do we need a recommender system?
Like to know what we exactly need based on activity.
Yes. But what is that important point where we say, yes, we need a recommender system? It is when we have a very big product catalog and it is not manually possible to skim through it to get what we want. Can you go through all the products in Amazon? No, right? Or can you see all the YouTube videos and decide what you want? No. So this is where recommender systems comes in. And why do we have to build a recommender system? So that answers that question. And why have you have to learn about recommender systems? For two reasons. One is for research projects, recommender systems are very good. Secondly, if you're trying to put it on your resume and go for any recommender system jobs, there's a plethora of jobs that are out there for recommender systems. To specialize in recommender systems is very good. What are the different types of recommender systems?
Media, e-commerce, software.
So basically there is content-based, collaborative, and knowledge-based recommenders. Let us see the intuition behind these. I'll share my screen. Let me know if you're able to see.
Yes, ma'am, you can see.
Yes. So this items and users. That is the crux of it. Any recommenders that you see, any recommenders in any part of the world, in any industry, in any domain, they'll have two things: items, users. But what are these items? Who are these users? That differ from use case to use case. Now, has this recommender system been an invention of artificial intelligence, or is recommenders an old concept? Can you tell about recommender systems that you have seen in the physical world and what you have seen around you, not just specific to the digital world? Because this will help you to understand how recommender systems got developed and what is the history of it. I have put a nice photo here. So can you link it and tell?
Like asking people for routes based on
Okay.
the experience.
Yes, that's a very good point. But do we have items there? Something that's more, you were almost there. You said asking people. So asking people for recommendation. Like earlier, when we didn't have Netflix or YouTube, you would ask someone who has already watched that movie and say, will you recommend that movie? And another very good example that we still see around us is a doctor recommendation. We just, when we have to consult any doctor, we just ask maybe our friends and neighbors, okay, there is this doctor in the neighborhood. Should we go ahead with this doctor? Is he reliable? Do you recommend this doctor to us? So recommender systems are there everywhere. If you see in any of the bookstores, physical bookstores that you go, there is the best-selling that they keep, 10 best-selling authors and multiple copies of those books. If you go to a grocery store, then, and if you want a certain product, they'll be able to tell from their experience, telling, hey, you need to go to this shampoo because this is good for this and this is running now. Many people are buying this and it's giving a very good quality output. So recommender systems are old concepts. It exists everywhere in all walks of life. Just a second. Yes. Okay. Yeah. Are you able to see me? Yes. Yes. So the reason why I'm trying to tell about these recommenders are that I want you to think that you are capable of building a recommender system. You are capable of understanding what is a recommender system. You are capable of doing research in recommender system because it's not something that's fallen from the sky, but it's something that has evolved in the society that we live in. So this is what I was talking about. Either it could be recommendation of a doctor, recommendation of a book, or recommendation of a movie. If you go to a bookstore, a very old bookstore, then you say, this is the kind of book that I would like to read. It says like, this is the kind of book that you need to take. Or you have a library and you want a book of a certain sort. Now, we see that we have come into the digital world and we have items like the e-commerce, and then we have media, the media recommenders like YouTube, Netflix, Amazon. Those are all media recommenders. And then we have item recommenders like the Flipkart, Amazon, Meesho, and all of that. Why are recommender systems important? I want at least 5 reasons to be given by this student community and professional community why recommender systems are important. Unless and until it's important, there's no point in doing it, right? What is the importance of recommender systems? And why is extensive research done about it? Why is it incorporated in all of the important businesses that we see? We already saw about the fact that we are living in a digital world and the catalog is very big. The catalog is very big. That's one reason. And can you tell me from a business perspective how recommender systems will help? Recommender systems, they increase the return of investment, they increase the business traction because when you recommend the items to people, there is a strong propensity that will make them buy it or view it, and this increases the business. And recommender systems mainly is for business, where we want each of this item that is purchased, each of this media that is viewed, it adds money to the coffers of the business. Third, recommender systems, they capture the trends that are there and try to recommend what is trending. So can anybody give me an example of a trend? A trend. I'll give a clue, like a holiday trend. Okay. Generally in the US and UK, European countries and all of that, there is this trend towards the Christmas where everybody will have, there's a Black Friday sale, there's everybody who will go and purchase items. So that's a trend. If we see from the Indian context, we see the Diwali trend. Around Diwali, there's a lot of home appliances that are purchased, gift items that are purchased. And another important trend that I would like to tell is, what are the items that are of interest during these trends? Like for example, during Holi, if you see, there is an influx of the pumps, the water pumps that are required for Holi playing. It could be that during Ganesha festival, there is a requirement of some form of puja items. Diwali, there is some requirement of candles. So these are in a showroom, right? Where, say something like Spar or Reliance Trends. They always look at trends and stock those items such that when the user, there's an influx of users, the
IAT language there. That's what I
yeah,
thought. But here's same option. So it's
yeah, you can go ahead. Who is this?
Hi, Yashaswini, Ambika here. Sorry, I was just logging in.
Hi, Ambika. How are
Hey,
you?
I'm
Thank you
good.
for
I'm
this
still,
opportunity.
yeah, you're most welcome. Sorry, I couldn't join because I'm in a meeting. Yeah,
Uh, I think we are good. The
okay,
audio, video, and is everything working? The screen share,
everything is going well. Okay,
all of
great,
that.
great.
Yes.
Sure, yeah. Carry on.
And
I'll catch up with you later then. Yeah,
yes, and they have been quite interactive also, which is
lovely.
very good for me.
Very nice. Sure,
Yes.
sure. Then sorry to break in, but yeah, please carry on.
Thank
Bye.
you, Ambika. Thank you for this wonderful opportunity.
You're most welcome.
So we see that recommender systems are crucial in order to increase the business value, and anything that is involving around money, right? People are ready to invest a lot of capital in it, funds go into it, research goes into it, and audits go into it. Can any of you unmute and tell me about these two things? Here, what are the items? What are the users? I will just recollect. Any recommender system will have items, users. We saw different recommender systems, like a doctor recommender system, book recommender system, movie recommender system, grocery store. We saw about e-commerce site. Now, can you tell here what are the items? What are the users?
In LinkedIn, it's like people with similar job may get the post of similar interest.
Okay. What about in Facebook?
Not Facebook. Like maybe it's posts.
Yeah, let's open the floor for others. For Facebook, it's a very easy answer. Uh, what are items and what are users in Facebook context? I'm sure all of you use Facebook. Yeah? Can you take a guess? It's okay if you're wrong. But I want you to guess. I want you to develop the intuition about recommender systems. And next time when you see it somewhere, I want you to be able to recognize it. Can any of the
Is it
students here?
similar to
Yeah, go ahead.
is it similar to Instagram reels or videos, or any people who are nearby us or somewhere related to us?
Here, people are the items. So we are trying to connect, we are trying to recommend people. We say, hey, you are like this, and maybe you can be friends with so and so. So the item here is people. The user is a Facebook user, but item is again people. So there are two sides, you see. You exist, and there is a pool of people who exist. How will you know whom to connect to? You will have a recommendation from Facebook. LinkedIn works on similar way. You have jobs and you have a profile. There's so many jobs in the world. How will you know which job to apply for? It'll recommend the job for you. Here, job is an item, and the LinkedIn user is the user. Okay, moving forward. Why do you think there has been a great need for recommender systems? What is that important technology that has ushered in and led to the requirement of a recommender system? Can you guess what is that technology that drove the recommendation? What is that technology that said, hey, we need a recommender system? What is that technology that had a big volcano of data that started coming? Can you give me some parameters?
Learning, no? Like
Machine learning, yeah, in the last decade and behind that, yes, we have machine learning. But there is one important technology that I'm trying to get here, which is something that all of you were born with. So maybe you do not know what it was to be before that era. It is internet. It is internet that ushered in the need for recommender systems. So one is people started using items on the internet. They started buying things. They started viewing things. And anything on the internet, right, it explodes. There is an explosion of information that is out there. And this explosion of information led to the need for recommendation and need for innovation in the space. Let us go ahead. So why should you learn about recommender systems? It's a niche skill. Not everybody understands recommender systems. Not everybody can work on recommender systems. So there are particular jobs which are for recommender systems. The particular jobs which require this niche skill. And it's a very good research area. Recommender systems is a very good research area where you can apply a lot of techniques. And it's a research area which is developing, and it has a lot of research already. So you can do your literature review and you can go ahead and do your innovation and have patents and papers in this space. And the third, it's the awareness. When we see recommender systems all around us, when we use recommender systems all around us, we would like to know how they work. So let me ask a few questions here. When we talk about e-commerce and movie recommenders, what is it that is existing there? Yes, items. I agree the items is existing, but what is existing there? What type of data is existing there? For example, let me go specific to, say, Amazon e-commerce. What is existing there for the item?
categories of items.
Yes. Go deeper. What is existing? We have categories, correct? Each item, what does it have?
Price ranges, locality, like place where we live in, or which is in trending items maybe.
Each item will have a product description. When we see any of the e-commerce sites, you will have a product description. Can you give me examples of items and product description?
Is it groceries or tech products or anything like that, like
You
categories?
can take a tech product. You can tell about a good Bluetooth mouse.
Wireless mouse or a wired keyboard or a printer like that.
Yeah, basically each of these items will come with a product description, and based on the product description, you'll be able to recommend it. And in the context of a movie recommender, do we have product description there? Movie descriptions?
Can we consider genre of movie as a description, ma'am?
Yes, we can.
Okay, then any film productions or genres or actors which are common in movies?
Yes. Now I would like to introduce, so that is called content-based recommender system. I would like to introduce collaborative filtering. Now, when you see the word collaborative, what strikes to you is multiple users. Now, if you see any of the media recommenders like YouTube or Instagram or Netflix, you see a lot of user citation, or what we can call it as user points that are given. N number of users liked it. And sometimes there will be a rating. Like if you see the e-commerce site, there's a rating. On a 5-star rating, either there's a 4-star given, or a 4.5-star given, or a 3-star rating. Based on this rating mechanism, you tend to either buy the item or not buy the item. So when we have a system like this, where we have a rating-based system, who gives the rating?
Users, ma'am.
Yeah, so we have users and we have other users who give the rating. And in this case, we call it as collaborative filtering because users help other users to filter out items which are good, which are of high quality. Now, knowledge-based is when you have, earlier there used to be a critic writer in the newspaper. He's having the expertise to know, to understand what are the items and which are the good ones. Those are critics. So they have the knowledge, they have the expertise to do the recommenders. Now, if we have a combination of these, right? And so if you see any of the recommenders that are already there, will it be just content-based or just collaborative? It's hybrid. You will have a mix of all these things that come together to give you a recommender system. Now, the second generation of recommender systems, there are matrix factorization, web usage mining based. Can you tell me more about personality based? I'm asking the easy ones. The tougher ones, I'll explain myself. The easy ones like personality based. Can you give me a personality based recommendation for a book recommender?
Is
Or a
it by
movie recommender? Go ahead.
fiction or any past searches?
See, when you talk about past searches, and when you say fiction, non-fiction, you talked about two important points here. The first is explicitly asking what is that interests the user and trying to build a personality. The other one is implicit, where you see the past activity and you derive what is that is of interest to this person. Then there is a very important kind of recommender system that is there. It's called the market basket analysis. This market basket analysis is a very important thing because majority of e-commerce, they use this. Like for example, if you buy a Bluetooth mouse, what is an item that goes with it? Like what else will the user want to buy if they have purchased a Bluetooth mouse?
Like mouse pad or
Yes. So how does this help with recommendation? You can tell the user when they purchase a Bluetooth mouse, you can tell them that a mouse pad could be of interest to you, and here are some nice mouse pads. Okay. Now, in the third generation of recommender systems, we see collaborative filtering using deep learning. We have gone into the deep learning era, and we can use collaborative filtering using deep learning, deep content-based recommender system, combining model of users and items using reviews, using neural networks. Okay. Now, at this point, let me quickly summarize whatever we learned. We gave a good introduction on what is a recommender system, why we need recommender systems, how they are working in the industry, and how do you have to upskill yourself with recommender system, and why do you have to upskill yourself with recommender system. Today, we will be doing two parts of this. So the first part of it is whatever I did now. I'll be telling about the recommenders. I hope all of you have understood what are recommenders. Do you all have your laptops with you? I will be sharing. I'll be sharing one important use case here where we have the movie lens data set. I will share the link with you, movie lens data set. See, data is very important when we are doing any of the research. Here we have movie lens data set. I want all of you to open this data set. Before we dwell into while everybody is trying to open this link, I want everybody to introduce themselves. Very quick introduction, your name, if you're working, where you're working, how many years of experience you have, what is the domain that you're working on. If you're a student, which branch of engineering you are studying and in which year you are. Can we start from Gayatri? Okay, anybody can unmute themselves and start off with it. But I would like to know the background of each of the students.
good evening, ma'am. This is Paranjay from
Hi, Paranjay.
Vismaya Institute of Technology, and I'm currently pursuing third year of CSB, Bachelor of Engineering in CS department.
Okay, okay. Thank you, Paranjay. Lena, would you like to introduce yourself?
Hello, ma'am. I am Leena from
Yes.
Vismaya Institute of Technology.
Yes?
Now currently 4th year of computer science engineering.
Yes. Vatsalya?
Yes, ma'am.
Yeah, could you please introduce yourself?
I'm Vatsalya from Christ University, and I'm pursuing my Bachelor's of Technology in Computer Science, and I'm currently in 3rd year.
Thank you. Suzanne Sharma? Okay. Manisha?
Hello, ma'am. This is Manisha. I'm also from Christ University, and I'm currently in my 3rd year pursuing Bachelor's of Technology in Electrical and Electronics Engineering.
Okay. Thank you, Manisha. Sudarshan? Sudarshan? Yes.
Hello, yes, sir. I'm S.Y. Solution from BTech, studying in Tripoli Christ University. I'm in my 3rd year now.
Okay. I think the only person left out is Gayatri.
Hello, me?
Yeah. Yes, I can hear you. I can hear you, Gayatri. Go ahead.
I'm Gayatri. I'm from Christ University.
Okay. I think we had a good round of introductions. I want one of you to open this link and share the screen. And I'll tell you why this data set is very important and how we can leverage on this data set and understand recommender systems. Anybody volunteering to open it in their laptop?
Mom, where can I find the link for the
I put it in the chat. It's grouplens.org datasets movie lens. That's okay. I'll share the screen now. So guys, be ready to share your screen next. I'll be sharing a notebook and I hope you all have the notebook with you. There's a Jupyter notebook that I had shared over mail. Rachika?
Oh, yes, ma'am.
I had shared a Jupyter notebook or mail. Do you have access to it or should I put that in the chat here?
I'll just check it, ma'am. Just give me a minute.
But I can always put it here. Only if you
Sure,
have.
ma'am.
Okay, I'll put it here. Okay. GroupLens research has collected data from MovieLens website and they have created this data set. So we have MovieLens 32M, 32 million ratings, 2 million tag applications. So you have 87,000 movies and you have 2 lakh users. And it says when was it released. So you have the other movie lens data sets here. There is the synthetic data set. There's an older data set, which will be used in many of the research papers. There's a 10M, 20M data set. There's a tag genome data set, 25M data set. The reason why this is important is already told here. And by using this data set, we will create a recommender system. Okay. I will share a Jupyter notebook here, and I expect one of you to open the Jupyter notebook and go through the Jupyter notebook, or I will give some time. Do you all know, how many of you know Python? Okay, Python is known. How many of you know how to do pandas?
I don't know.
Anybody knows pandas? How to work with pandas?
Yes, ma'am, a little bit like to work with CSV files.
Yeah, data frames.
Yes, ma'am.
Okay, okay. What about others? So I'm just trying to Rachika, will it be possible for you to give me your email ID? I will forward to you.
Sure, ma'am. Shall I send it in WhatsApp or shall I drop it here?
You can, that's left to you. So while Rajshekar is giving his email ID and while I send the mail to him, how many of you here are well versed with Jupyter Notebook? Opening a Jupyter Notebook. Opening a Jupyter Notebook, working
Me.
with it cell by cell.
Ma'am, I have
All of,
shared my email ID in the chat.
thank you so much. I will share a Jupyter Notebook. Okay.
Sure.
I have shared it with you, Rachika. So kindly share it with all the students here so that we can work on the Jupyter Notebook. So I will, let us work with this. I want an interactive session and the use case is a movie recommender system. So when I say a movie recommender system, what is the first thing that you want? you need a catalog of movies. And that this data set will give you. This data set will give you the catalog of movies. Once you have movies, can you guess what type of recommendation is possible? Content-based or collaborative or knowledge-based or a hybrid of all of these? Something simple. Like Paranjay told that time, we can use the genre of the movie and do content-based recommender system. Okay. Secondly, now we have the set of movies. We have the genres of them, and we can use content-based and do the recommender system. The other important way of doing is the clustering. We put in similar movies together, and we recommend from that cluster when somebody views a movie in a particular cluster. So clustering is a method that we use in order to group similar movies together. Similar genre movies together, we try to do that. Then we have the user ratings. User ratings are used for collaborative filtering, and people with somebody who has liked a particular movie and rated it well, we will recommend similar movies to them. Okay. Now, while Rajshekar is pulling up the Jupyter notebook and sending it across all of you, I want one of you to share your screen and we'll start building out the notebook. Paranjay, would you like to share your screen? We will build out the notebook. Leena, Vatsalya, Susain, Gayatri, Manisha, Sudarshan.
Yes, ma'am. Yes.
Okay.
Yes.
I want everybody to keep their Google Colab ready, and Rajshekar will be able to give the notebook. I do not want you to see the notebook solution at the outset, but I would like you to try on your own first. So let us build it together. Okay.
Hello, ma'am. So I have downloaded the notebook and uploaded it to a drive folder. So I'm sharing the drive folder link in the chat so that everybody will be having access to it.
Yeah, that will be very helpful. Thank you.
I have shared the drive link.
Super. So let me pull this up. Now I want to first of all brainstorm on how will we go about building a recommender system. I will quickly call upon few students here. So the first one is Vatsalya. I want Vatsalya, Manisha, and Sudarshan and Lina and Liana to come on audio, and Suzanne also to come on audio, and we will have a discussion on what the recommender system should be and how do we have to build it.
Okay, ma'am.
Yes. Lina, can you tell me how do we start with it? What is the first step?
Taking the user interest, ma'am, like on which domain does he is interested in, like on which genre.
Got it. That is personalization. So we have three things: search, personalization, recommendation. What you said is more of personalization, that is taking the interest of the user and trying to specify that particular movie to them. Let us hold on to that. Manisha, Vatsalya, and Gayatri, can you tell what is the starting point?
Yes, ma'am.
Yeah, can you be a bit louder?
Yeah, ma'am. Can you hear me now?
Yes.
Ma'am, wouldn't it
Yeah.
be like collecting data or like finding out what we are trying to build first?
Yes. Okay. Okay. Vatsalya, Gayatri, what do you have to say? So data. So first we need data. How do we upload the data? What is the format of the data? Did any of you download from GroupLens website? So let us go to that. Let us pick a smaller data set which you can download now. There is ML latest small zip. Can you download that? I want you to download the small data set. ML latest small data set. Can you all download it? Paranjay, are you sharing the content? I'm not able to see it.
Mama, I have a network issue, like I'm trying to.
Okay. Okay. So everybody please download the data set. I want all of you to put in the chat, download it. You need to put a yes after you download. We have roughly around one hour to do this. So let's be quick. Okay. So I want all of you to download the data set and put a yes here. Very simple. At every step, I will ask a confirmation from all of you. And once everybody confirms, I'll go to the next step. Even if one student is able to do, I will move to the next step. Okay. So step one, download data set. Identify data set. Download it. Once we download the dataset, can somebody tell me what is the next step?
Clean the
We
data
need to
set.
read the dataset. Yes, you need to read the dataset. Okay. For reading the dataset, so generally this Google Lens dataset, it comes in CSV format. We need to be able to read it from the CSV format. And where do we put this data? In order to work with the data, we need to put this data somewhere. Where do we put this data?
Data frames.
Yes, data frames. We need to put it in data frame. And we need, can any of you do these steps? Download, upload, read the data set, and show me the head of the data set. I want you to share your screen and show the head of the data set. I'll give 5 minutes time to do all these 3 steps. Download the data set, upload the data set to a Google Colab, and read the data set. Okay. If you share your screen, I'll be able to help you to do it. And let us build this, because building this is important. Knowing what is a recommender system is also good, but able to build a recommender system is what is the key takeaway of this session. I want you to download, upload, read it, do a head of it. So it's called head. When we do a head, you will know the first few rows. Okay, I'll give 5 minutes for this. Yeah, anybody able to do that? Anybody able to come to this stage? Super, super, Prananjay. I think we will go ahead and cover the next. Prananjay, are you able to do a screen share of the notebook? Then let me do the screen share of the notebook. What you can do is you can try to implement it at home and build out a recommender system. Okay, a movie recommender system. I will try to open that. Meanwhile, Prananjay, do try to share your screen. Everybody else, are you able to come to the head position? That is, you download the data set, you upload the data set, and then you read the data set using Pandas data frame. And then you do a Pandas head.
See my screen.
Yes, ma'am.
Paranjay, can you share your notebook? Yashaswini, can you see his notebook, or is it just the screen that we are seeing that you're? You're on mute. You're on mute.
At this point of time, I can see only the screen.
Yeah. Yes. Yeah. Thanks, Paranjay.
Okay. So when you, can you start running from the start? Okay, that's the first one. Before we move into actual coding and trying to solve the problem, so we saw that first step is to get the data set. The second step is to see the head of the data set. Yes. Now, do you see what are the different types of data that is available? There is nominal, there is no ordinal, and there is the integer data type. So if you see, yeah, can you open this? Can you open the notebook that I have shared? Yes. Now, we have movie ID, we have title, and we have genre. So what is the type of recommender system that we can build here? It's a content-based recommender system. Now, the genre, if you see the genre, yeah. If you see the genre, we see that it's in a string format, which is having the bar symbol to demarcate between the different genres. Now you need to write a piece of code to do. So can a computer understand string? When you give this and when you want it to do some of the machine learning algorithms over it, you should be in a position to give numbers for it. So that is where the importance of one-hot encoding comes. I repeat it, one-hot encoding. What do you do in a one-hot encoding scenario? Anybody has come across one-hot encoding? Okay. One-hot encoding is where we take categorical data. We take categorical data and we apply this one-hot encoding and we get zeros and ones.
Value to a category.
Yes. Can we do that now? I want, in the interest of time, I want you to go to the notebook that I have shared. Copy the code that is there to convert the genre from categorical into one-hot encoding. Yeah, do we still have Paranjay here? Paranjay, are you still there?
I think the net is little slow, Yashaswini, so we'll just give him some more time.
Yes.
Yeah.
Okay, while Paranjay comes back, I would like to discuss the next steps. So we need to do one-hot encoding. When we do one-hot encoding, we take the categorical value, we take the genre, and we convert it into zeros and ones. The way we do it is, we calculate the complete total number of genres, okay? The complete genre list, unique genres, and we have that as the column header. And then we assign 0 and 1 if the genre is there. Like for example, if we have animation and children, animation bar children, we will have 1 for animation and 1 for children. The rest of the columns will be 0. This is one-hot encoding. To do one-hot encoding, if you go to the Jupyter Notebook, there is a particular code which is converting that categorical into one-hot encoding. Once you do the one-hot encoding, you will have a data frame that has the data, and it will have the name, the movie name, and a one-hot encoding of the movie categories. Now we can go to the next step.
Ma'am, I think even Leena is done with loading the dataset, I guess. We can ask her to share the dataset if she's okay.
Anybody can share. Now we are in the next step where we are doing the one-hot encoding. We're in the next step.
Lina, will you be able to share the?
Yes, 1 second.
Sure.
Are you able to see my screen, ma'am?
Just give me a second. Yes, I'm able to see your screen. You're okay. Yes, this is a Jupyter notebook, right? Okay. Now, the code that you see in cell number 22 is converting this genre into 0 and 1. If you're able to come to this level, can you run that cell? That's okay, it has worked. And now can you do movie data.head? Mm. Can you go to the notebook that I have shared?
Ma'am, are you able to see my screen?
Just give me one second. So what we will do is, yeah, I'm able to see your screen. Yes. Let us debug. Okay. Let us see what we need to add in order to get the one-hot encoding. So you need to go to movies data and dot head. Okay. So the genres have to be converted into 0 and 1 using one-hot encoding. The code that you have written here will give the one-hot encoding. There is one little piece that you're missing. because of which you're not able to see? Can you do movie data dot genres dot value counts? Yes. Okay. And then can you run that? The one where you're doing the one hot encoding, can you run that? Can you scroll down? One hot encoding. Can you copy the one hot encoding here? One hot encoding code here. Yeah, now can you run it? Now can you do a head of movies underscore data? Okay. So basically, the one hot encoding has to happen. Movies underscore head should be having zeros and ones. So let me show it in my screen. I shared my screen and we can see what we need to do together.
Hello, ma'am.
Yes.
I'm sorry I lost my network while sharing the screen.
Don't worry, don't worry. Don't worry. Okay. So we did all the imports of all the libraries that we need. Then the data set, we need to have movie lens, movies.csv. Can you see how to do the one hot encoding? Meanwhile, you need to do the one hot encoding and get it into zeros and ones.
Can others see? I'm just seeing a white screen. Ratikar, you're able to see the screen?
No, mom. Even I thought the content was loading. I think even I see the blanks.
I'm quickly loading the data so that I can debug here also
Sure.
why they're not able to do the one-hot encoding. There has to be some little bit that is missed. It's a
True.
very simple code. So I just want to, we will just do this for the next 5 minutes and then move to the agent part that I'm trying to cover today. So I'm just trying to see where we will be able to see movies data with one-hot encoding in the notebook that we have. At what stage we'll be able to see that? Let me show how that one-hot encoding looks like. So here, if you see, this is how the one-hot encoding looks like. Say, for example, comedy, you have 1. For all the rest of the columns, you will have 0. For comedy, data, romance, comedy is 1. Sorry, not data. So not data, it's drama. Comedy, drama, and romance. So the romance column has 1. So this is how one-hot encoding will be. The code that you are trying to use that will lead you to doing this one-hot encoding. The code is right. Okay, it's a working code that I have shared with you. After the session gets over, I strongly suggest you go over this code, get the one-hot encoding, then you do what we call as k-means clustering. What is k-means clustering is you will have centroids and make clusters of similar movies together. And then when a particular movie in a particular cluster is watched, you suggest other movies in that cluster for the user. So that's how a movie recommender system can be built. See, this is just one way in which you can build a movie recommender system. There could be multiple other ways using which you can achieve the same target of building a recommender system. The reason why I'm giving this notebook, the reason why this example is taken is having a base recommender system that is ready will help you to build on top of it. Say now you have a k-means based clustering, then you can go for, you can take the user ratings and do collaborative filtering. Say next, you can take a step further and do knowledge based and do a hybrid recommender system. And as one of the students was telling, you can take personalization. That is, you can take what movies they like, what genres they like, and specify using the genre. Yeah, here is the k-means plot that is there. We can see that as the number of cluster goes, we see, this is called inertia. Inertia is where the clustering ceases to change. So when you do the clustering will happen with the centroids, and the centroids will keep moving. The clusters will keep changing. But at some point of time, you will not see a change in the clusters. So here is the inertia that we see. So if we take 40 as the optimal number of clusters, we can do the clustering using k-means. And then we want to give an explanation why a particular movie was recommended. We can use trees. We can use a tree model decision tree classifier and get the classification for why a particular cluster was selected. Like this. So if you see here, you will see why a particular, this is the decision tree classifier for why a particular movie was selected. And then this is, so we see here, we see the movie title, we see the genre and the one-hot encoding. And then this project, it builds out, it first gives you 10 movies. And then based on whatever you select, you can go to the cluster, get other movies from that cluster, and put it as a recommendation. This notebook also tells about how you can give the explanation why a particular movie was selected. It gives the explanation, and it also gives you how you can specify the explanation. Do you do it in an audio modality, or do you do it in a text modality? Is given in this. So if you see here, you can see these are the exploratory that you can do. Say you say Jack can give something to ignore that he does not want to see. And so here Jack is a user. Whenever we see, we have exploration and exploitation. Exploration is we go to newer domains, we go to newer types of genres, even that Jack has not seen before. Exploitation is whatever he has seen, we exploit that and we give similar ones. There is a filter bubble that will happen if we go on doing exploitation. What is this filter bubble? Is echo chamber or filter bubbles. It is the same kind keeps getting recommended, and the person may get bored of it and may not see the movie and go from this media to another media. something like from Netflix to Amazon because they get bored of it. So that is why we need to have both exploration and exploitation. So here there is code that talks about exploration and exploitation. Now, whatever we have that is given in the textual format, and here this particular project talks about an audio explanation where the audio comes up to say, hey, this is the movie that was seen, and this is the movie that is recommended, and this is the reason why it was recommended. When you're seeing Netflix or YouTube, do you see any audio recommendation like that? Do you see textual, right? You see textual recommendation, and that says how you innovate in the recommender system space. Now you have the notebook with you and you can build it out in your free time. We will go to the next segment now, and that is Agent AI. We have generative AI now, and yeah, just come back. I'm sharing my screen, and I'm teaching about agents now. The reason why learning about agents is important is I'll be sharing a paper called Agent for Rec, how we use Agent AI and build recommender system. Now, this is the era of generative AI. All of you know how generative AI is important, why generative AI is important. This is a generative AI use case where we have Agent AI building out the recommender system. I'll first tell what are Agent AI, and then I will share the paper with you, and you can try to use that to build the recommender system. So what are AI agents? Can anybody unmute and tell that? Take a stab at it. Take a guesswork. That's okay. I think we have half an hour now. Okay, we have 20 minutes and we will complete by then. What are AI agents?
Are AI agents something which does a particular task?
Yes. Agents are autonomous units. They do tasks and they make decisions. Earlier, when we used to write code, that code used to follow whatever we write, instructions. But now in agents, it is capable of making decisions. It is capable of communicating with other agents. Say, think of an agent like a member of a team. Each agent will have some skills. And when there's a particular job to do, they all come together. They will have different roles like researcher, writer, recommender, and each contribute to the overall goal of the crew. What is a crew? A crew is a set of agents. What is a task? Tasks are specific assignments completed by agents. They provide all details necessary for execution. A description of the task. What is the agent responsible for? Which is the agent that is responsible for it? What are the required tools? And facilitate a wide range of action complexities. What is a tool? A tool is a skill or a function that agents can utilize to perform various actions. Here, I'm trying to give something practical, that is Crew AI. You can try to see Crew AI Toolkit, and LangChain. I will put it in the chat here. Crew AI and LangChain. So Crew AI and LangChain, by coupling them, you can create this agent AI workflows. What is a process? So we can orchestrate process. You orchestrate the execution of the task, like project management in human teams. These processes help in making a strategy. Collaboration. Collaboration is, again, there are different agents with different skills, and they share their information, assist each other in task execution, and they have an ecosystem. What is that particular thing about agents that make it different from other components that work? They have memory. They have sophisticated memory system which significantly enhance the capability of AI agents. There are different kinds of memories like short-term memory, long-term memory, entity memory, contextual memory. The purpose of each of these kinds of memories is different. And it will help the agent to remember, reason, and learn from the past interactions. So here are different types of tools that are there. You can see a Google search, browser-based web loader, scrape website, directory read, file read, so on and so forth. So here you also see the word RAG search, that is retrieval augmented generation. When we have to ground an LLM, a large language model, when we have to ground it, that is when we have to give context to it and tell you need to take the information from this and give the answers from this particular set of documents. We say grounding, and we call that retrieval augmented generation. So you have that as tools in Crew AI. This is the summary of whatever we discussed. There is a self-reflection or a cross-reflection component that's there. So the agent will know what it is trying to do and try to do the task, the specified task. So if you see here, there is custom data with RAG. There's reinforcement learning. We saw about short-term memory and long-term memory. There's also the RLFH, the reinforcement learning human feedback and the reinforcement learning AI feedback. All this put together makes agents. When we talk about agents, we have the conversational AI agent or the customer service agent, the automated follow-up agents, the ticketing resolution agent, language translation agent. Here we are trying to build a recommendation agent. We have the infrastructure like AWS, GCP, the models like Mistral, OpenAI, Gemini, the platforms like Vertex AI, Microsoft Azure, Crew AI. If you see an AI agent ecosystem, right? You will have foundational models, you will have tool builders, tools, graph stores, multimodal data stores, tool aggregators, vector stores, and autocritics. I will be sharing this slide deck later so that you'll be able to go in depth and see what are the different combinations that you can have. What are the different ways in which you can build out a recommender system using agents? So you have agentic workflow here. How you can have data source systems, the data pipelines, feature store, model experiments, model deployment, the agent AI core, workflow optimization, autonomy, adaptable planning, reasoning, language understanding, and then you have the Docker and front-end application. This is a complete ecosystem that is here. An LLM agent, typical LLM agent structure, it'll have knowledge, it'll have memory, it'll have instructions, persona, tools, and interface. Here, we see what is the profile of an agent, what is the memory of an agent, what are the planning capabilities with or without feedback that is available for the agents, and the actions that they take care of. Then we have multi-agent systems where multiple agents come together to do tasks. Again, these multi-agent systems, we have something called mixture of agents. And we have the last bit that I want to leave you with is meta agents, that is agents writing agents. Now, I want to show this. I will share this link. Recommendation systems on Google Cloud. So take this as an exercise. I will put it in the chat here. You can take this as an exercise. Google Skills Post. There's a complete course on recommendation systems on Google Cloud. So it tells about overview, different types of recommendation system, and what are the common problems that arise while developing this recommendation system. Then it teaches content-based recommendation system and how you can do it using Google Cloud. Then it talks about collaborating filtering recommendation system and how you can do that using Google Cloud. And then neural networks, how you can use neural networks and do and you can do recommendation system. And the last bit is the reinforcement learning. In order to know how recommendation systems are built in the GenAI space, here is a research paper that is there that I'm putting in the chat. You can see that, how you can see generative AI that's coming. And let me show the agent for rec. Agent for rec. Code is also available for this.
I found this on the web.
Sorry. I tried to pull the GitHub of agent rec and this is the Git of agent for rec, and I will share the paper with you. So this is you can do your courses here on Google Cloud, and you can implement this paper, this code that's already there. I would like to tell about ACM Rexes. It is the conference for recommender system. It happens once a year. If you write good papers, good research papers here, you'll be able to publish here at Recommender Systems. It is a coveted conference, and it's a great thing to have a paper in Rex's Recommender Systems. You can also go to Rex's and look at the papers that are published earlier and see what is the latest and the greatest that is happening. It gives the complete overview. So generally, if you are specializing in recommender systems, you need to put in some effort, like 2 to 3 months, get up to speed and learn all about recommender systems in the area and be up to date with what is happening in that region of recommender systems. But I have to say, it's a very good field to have a specialization with. It's valued everywhere, both in the industry and in the academia. And now I open the floor for questions. I'll be able to take questions. And if there's any other information that you require about recommender system, where to learn recommender systems, and what to do. Okay, if there are no questions, then we will close the session. It has been a wonderful session teaching all of you, and I hope you continue learning. I hope you build out the book and then continue learning. I hope you take the Google Skill Boost and get a badge so that you can put it on LinkedIn, and you can show it even in your resume. I hope you build out some research papers and try to publish in Rexus. And one day I would like to see all of you at Rexus. So all the best to everybody. I'm open to mentoring. You can find me on LinkedIn, Yashaswini Vishwanath or Yashaswini Vismaya. You can find me on LinkedIn. And if you're doing your final year projects on recommender systems or mini projects on recommender systems, I'll always be open to mentor you, and all the very best. And thank you, Ambika, for giving this opportunity to teach these wonderful students. They have been very receptive and interactive, and it's wonderful to teach them.
Hi, Yashaswini. Thank you so much for agreeing and coming by, and then having the session for the students. I'm sure they've had good value from the session. I'm also learning. Probably, we'll connect and see. In case students need anything more from you, we'll reach out to you.
Thank you. Thank you, Ambika.
Yeah.
Bye.
Shall we take a picture? One picture, all of us? Manisha, Paranjay, and Leena. Rachika, you too? Shall we just take one picture? Manisha and Paranjay.
Paranjay was very enthusiastic.
Yeah,
I have to say,
I
you'll go
know.
a very long way in life, and you will do
Very
some amazing stuff. Yeah.
absolute. Okay, cheers. We'll take one snapshot now. Yes. Rachikar, I'll take one and you take one, okay, so that I have a picture in yours. Yeah. Thanks, Yashaswini. Do you have an email ID where students can reach out to you in case they're looking forward to?
Yes, I'll put it right away.
Sure.
It's yashaswini.cac@gmail.com.
Okay, in the meanwhile, ma'am types her email ID. I would take a minute to give a proper thank you to ma'am for such a wonderful session. Thank you, Yashaswini Vismaya ma'am, for guiding us through an insightful session on recommended systems. Your expertise and clear explanations have greatly enhanced our understanding. And it was really great to understand the similar concepts of Python, which we use in normal machine learning prediction algorithms in a recommender system possibilities. So thank you so much for taking us through the whole journey, ma'am. Thank you so much.
I just have one last bit to tell. How will it be if the students who came here, you take the agent for rec as a project, because that is, agents are the future. Okay, generative AI is what we saw last year. And if you see Andrew NG, that is what he says. Agent AI is the future. And having a recommender system, which Agent AI is building out, and having it in your resume adds a lot of value. And the second point is Agent for Rec is a latest paper in 2024. So if you can build out on that, they have given their code, take it as a project. All of you can come together virtually and develop it. All interested students can come together virtually and do that. That's a very good use case.
Absolutely, yeah. Just